morning, students. So we'll see the different basics of the electrical engineering, which is the introduction. So if you come to the electrical engineering, first thing is you should know what is the voltage, what is the current. So in our previous video, we have observed what is the Ohm's law. So what is the relation between the current and the voltage? All these things we have observed in our previous video. Okay. So today we will see, and also we have observed what is the basic circuit. So for a circuit, first thing needed is a source, okay, and some elements. So generally the basic circuit elements will be, we will call it as RLC. We will call it as the RLC circuit. So which is resistance, inductance, and capacitance. So the energy, the source which we are giving, so this is consumed in the form of the resistance or the inductance in the form of the capacitance. So this is the basic circuit. So we will say that the basic circuit elements are the resistance, capacitance, and inductance. Okay, we will call it as the RLC circuit. So here the source we will be calling as the active element, and remaining is passive. These three things. So since these are not able to generate, they will just absorb the energy. So we are calling it as the passive elements. So we'll see. So capacitor. Capacitor is nothing but two conductors separated by an insulation medium or insulating material, okay, or a dielectric. You can call it as dielectric material. So what is the capacitor will do is it will store the charge. It will store the charge, or we will say it will store the electric field. So it is represented like this. See, so these are two plates, and the gap represents the dielectric medium. So these are the actual capacitors. So as I said earlier, it is a passive element, and who invented? This is in October 1745. Okay. So this is about the capacitor, and the units for the capacitance is the farads. Next we will go for the another passive element in the circuit. So that is the inductance. So it is also a two-terminal. We can say yes, the source is a two-terminal element. The resistance, which we represent in the form of a triangular wave, it is also a two-terminal element. And also a capacitor, it is also a two-terminal element. And similarly this inductor. So inductor we will represent like this. Okay. So this is our inductor is also a two-terminal element having n turns. So number of turns will decide. So it will be looking like the solenoid actually. So what it will do is it will store the electromagnetic field, and the units are henries. So this is about the inductance. So this is the symbol, and by the Faraday. Okay. So next, resistance already. So it is we will be representing the resistance in the form of the triangular wave with a two-terminal. So it is a two-terminal element. So it is a property. It is the property of the material which opposes the flow of the current. So we will say R. So if I say What is the property of the material which is allowing the flow of the current? So, that is inverse to the resistance. That is inverse of the resistance. So 1 by R, you say it as G. That is called as the conductance. So that's why the material, if the material is having more conductance, we are calling it as a conductor. If it is having less conductance, we are calling it as a semiconductor. And more resistance, we are calling it as a insulator. So already we have discussed in the previous class Ohm's law. So it states that the current in a conductor is proportional to the applied voltage. So power is nothing but the product of the voltage and current, and we can also write like this: I square R or V square by R. So the symbol for resistance will be like this: side V of a cap, and conductance should be reverse, exactly reverse. And the units also ohms for the resistance and mohs for the conductance. So similarly, inductance mathematically, if you want, so we'll be saying V is proportional to L into dI by dt. So L is the proportionality constant. Okay. So the voltage is directly proportional to the current, rate of change of current. Okay. This will give the equation. And similarly, the relation between the charge, voltage, and the capacitor is charge. So if the voltage is more, we'll be having more charge. Okay. Charge developed is proportional to the voltage, and C is the proportionality constant here, which represents the capacitance. Okay, it stores the field, electric field. Okay, so these are the different formulas which we'll be using to solve the problem. So if I want to write the resistance, so voltage, so that is equal to IR according to Ohm's law, and the same resistance and current relationship is I is equal to V by R. That is also by Ohm's law. And power P is equal to V into I. And if you come to the inductance, so the relationship, if I want the relationship between voltage and inductance, I will let as V is equal to L into dI by dt. And similarly, current and inductance relationship, I is equal to 1 by L into integral V into dt. And the power, Li into dI by dt. And capacitor, so V is equal to 1 by C into integral I into dt. So this is the voltage and capacitor relation. If I want a current and the capacitance formula, I is equal to C into dV by dt. And similarly, power P is equal to CV into dV by dt. So this will be useful for doing small problems. Next we will see first law is we came across is the Ohm's law. So which we have used, which we are going to use. So depended on this Ohm's law, next Kirchhoff's developed two laws, Kirchhoff's laws, namely that is KVL and KCL. So now we will see KCL. So at a node, so that means where the two elements in a circuit will join, two or more elements in a circuit will join, the algebraic sum of the currents at a node is equal to 0. Or we can say the same thing as the sum of the currents entering at a node, sum of the currents, and sum of the currents leaving at a node. So leaving. Okay. So sum of the currents, entering currents equal to leaving currents. Okay. Or entering currents plus leaving currents is equal to 0. Or we can simply say that algebraic sum of the currents at a junction or a node is equal to 0. See here, so there are charges Q1. If you observe, only one charge is entering, okay, but Q2, Q3 and Q4 are leaving. The number of charges leaving or currents, we can say, are leaving are more. But if you add all these things, it will be 0. The charge entering, so even though it is only one, is equal to the charge is leaving, so that is Q2 plus Q3 plus Q4. So this is what Kirchhoff's current law says. And we'll proceed with another example. If you observe here, so this is the junction. So I1 and I2. So this is reverse case. So here only one thing is entering and three things are leaving. And if you observe, two currents are entering and only one current is leaving. But then also we will say that I1 plus I2 is equal to I3, or we say I1 plus I2 minus I3 is equal to 0. So this is what the Kirchhoff's current law says. And we will see another example, similar example. See, so what are the currents? So we will take the negative symbol for the currents leaving. So first we will write what are the currents entering. So I1 is entering. I1 plus I2 plus, and what are the remaining currents which are entering to the junction? I1, I2. So remaining things are leaving. So we write it as minus I3 minus I minus I5. Okay. But plus is entering. Plus, but I6 is entering. So we write it as I6 is equal to 0. So this is the simple form of understanding the Kirchhoff's current law. So with the help of this KCL, so the algebraic sum of the currents at a junction is equal to 0. And Ohm's law, V is equal to I R. We are going to find a method, an analyzing method, which is called as the nodal analysis. So because so KCL, it is telling that at a node, so we will call it as the nodal analysis. Next thing, so this is another example. We'll move forward. So he's asking about this diagram. There is unknown resistance, unknown current we have to find. So he has given a junction or a node. So we have to find this unknown current value with the help of this known current values. So some are entering and some are leaving. But we know what the KCL says. So that's why. So with this, we'll write it as what are the first we will write what are the currents entering. So that is equal to, so 1 ampere is entering plus 2 ampere is also entering, and 7 is leaving, and this unknown current is also leaving, and again this 2 ampere is leaving, and again 3 ampere is leaving, and again 2 ampere is entering. So that we will write as 1 plus 3 plus 2 5, and the currents leaving are 7, 2 and 3, so that is 12. So it's 5 minus 12, so that you get the answer as minus. So 12 minus 7 is 12 minus 5 is 7. So we are able to find the unknown current at this junction. So what are the currents entering? So 1, 2, 2, and currents leaving 3, 2, I and 7. So that we have written as 1 plus 2 minus 3 minus 2 minus I minus 7 plus 2. That is, we will get as the unknown current as minus 7. So here also we will try to find this unknown current, which is called as Ix, with the help of this case here. So first we will see what are the, we will assign the positive for entering and negative for the leaving. So 2 is entering, 3 is entering, 5 is entering, 1 is leaving, and 2 is leaving. So there is, so 3 is entering, so plus 5 is entering, plus 2 is entering, plus 2, another 2 is entering, and this 1, so this 1 is leaving, so we write minus 1, and Ix is also leaving. So if you solve, you get the answer at the 11 amperes. Okay. So here also, so 5 is entering, so 5 plus 5, I is leaving, so 5 minus I, 10 is leaving, minus 10, and 12 is entering, plus 12 is equal to 0. So that we will get as the 7 as the answer. And now we will see the Kirchhoff's voltage law. So what he says is, in a closed loop or a closed path or closed mesh, so the algebraic sum of the voltage is equal to 0, or the voltage sent is equal to the sum of the individual voltages. Source voltage is equal to sum of individual voltages. So here you can observe here. So here there are 4 voltages. So according to this voltage law, so V1 plus V2 plus V3 plus V4 is equal to 0. So what he said at the current, so the sum of the, at the case here, sum of the currents at a node is equal to 0. Here also the algebraic sum of the voltages at a closed path, in a closed path is equal to 0. So we will go for another problem here. See, the circuit is like this. So there are 2 sources and 3 resistances, namely 2 ohms, 8 ohms, 30 ohms. So you will get confusion. So there are, if there is single source, you can easily write. But what to do? So we'll take the highest source, that means 100 is highest. So we'll consider the 100 volts as the source voltage. That is equal to the sum of the remaining voltages. Okay. So according to it, first we have to redraw this circuit because it is twisted. The circuit is twisted. So we'll redraw in the normal format. So we'll get like this. So here 100 volts and 40 volts. So here the current, so we have to consider the highest source. So this 100 volts. So the current will start from this positive, it will go like this. So this is also a source actually, but this is also a source. So the current also will start from here, which opposes this main source current. So we will take it as it is opposing. So we cannot add. So it will be the opposite side. So 100 volts is equal to, so here he has given the resistances. So he has not given the voltages. So if he has given directly voltages, we will simply add and we will say that is equal to 0. So here that is not the case. So he has given only resistances, but we have assumed the current here. So that is I1. So this is a series circuit. The current will be same. Okay. So that current is I. We have assumed as I. So with the help of this I know the current. That is assumption, but that is I, and I know the resistance, that is 8 ohms. So with this, according to Ohm's law, the voltage I can write. So V is equal to IR. So I cannot directly write V. So but I will write it in the indirect form. That is, so resistance V into I. V is equal to IR. I is this I, capital I, into R, resistance 8. So 8 into I plus, and this source is opposite. So plus 40 and 30 ohms. So resistance 30 into the current I. 30 into I plus 2 into I. So if you simplify that, you will get as 40I is equal to 60. This 40 will go that side and it will become 60. So 40I is equal to, so 8 plus 2, 10 plus 30. So that will become 40I. So 40I is equal to 60. So I is equal, so according to Ohm's, I is equal to V by R. So 60 by 40. That is the voltage. Okay. So I is equal, that will be 1.5 amperes. You got the current. So now you are able to find what is the current here. Okay. So after knowing the current, so he has asked what is the resistance of the 30 ohm resistance. So you know the current will be same in the series circuit. Okay. The current will be same in a series circuit and voltage will be same in a parallel circuit. And series circuit acts as a voltage divider and parallel circuit acts as a current divider. Okay. So according to Ohm's law, V is equal to IR. So we know current. So current will be same. At any place, he has asked for 30 ohms. So 1.5 into resistance is 30. So that will get 45. So similarly, you can find for any resistance in the circuit. And we now will see another thing. So what he is asking. So he has given the source, ascending voltage, and different voltages he has given. So he has given the voltage at this resistor is 2 volts, at this resistor is 1 volt, at this resistor is V1, unknown resistor, unknown voltage here. Here also some voltage will be there. This is unknown voltage and 3 volts. Here the voltage at this resistor is 3 volts and voltage at this resistor is 5 volts. So now we can easily find with the help of this KVL. So that is sending voltage is equal to the sum of the individual voltages. So from here we start. So 2 volts, 2 volts. Next thing 1 volt, 2 volts plus 1 volt plus V1. We don't know V1. So as it is, we'll write it as it is V1. And next thing is 3 volts plus 5 volts. So now if you simplify, you will get the unknown resistance, that is 30 minus 11. So that is equal to the 19 volts. Okay. So this side there is 30 and this side there is, if you add 11 plus V1. So V1 will be 30 minus 11. Yeah. So see, like this we can find the values in the circuit with the help of the KCL at a junction, different currents, and KVL voltages. So here the series circuit has only one path. So if there are see, you observe here. So this is the source. Okay, and the current has started from here. It will start from the source. It will start from the source default. That is the only way. So from the source it has started. It came here, and afterwards also the same current will pass to this resistor also. The same current will pass to this resistor also. because the current, this source current, the current which has started from the source has not find the second path. So series circuit means only single path. So current does not require to divert to another path because there is only one single path. So that's why in a series circuit the current will be same. What is the resistance in a series circuit? So we will observe the help of this circuit, and also we will apply the KVL. So this is the source voltage. Source voltage is equal to sum of the individual voltages. So V is equal to, so the voltage at the R1, I don't know, is V1. We will assume it has V1, and at R2 is V2. So V is equal to V1 plus V2. So V1, with the help of the Ohm's law, we can write as I into R1. The resistance is R1, but current will not change. So I into current will be I. That's all. It won't change for V or V1 or V2. So V1 is equal to I into R1. V2 is equal to I is same, but the resistor is different. So we will write as I into R2. So here V. So I is same, and for V, R we will write. So IR is equal to IR1 plus IR2. So if you cancel these currents, we will get as R equivalent is equal to R1. That means these resistances are connected in series. We can simply add and we'll get the equivalent resistance. So for that example is, so here source voltage 12 volts, R1 resistance 680, R2 1.5 kilo ohm, R3 2.2 kilo ohm. So no need for applying KVL anything. We can simply just add. So R equivalent or total resistance is equal to R1 plus R2 plus R3. So that is 680 plus 1.5 kilo ohm. So we'll simply write it as 1500 ohms plus 2.2 kilo ohm. So that is 2200 ohms. So that is 4380 ohms. That we can write as 4.38 kilo ohms. So that means in a series circuit, or finding the equivalent resistance, we can simply add. Here also voltages we have to add. So V1 plus V2 plus V3. So 9 plus 9 plus 9, that will give the 27 volts. If you go to the parallel circuit, you see. So this is the parallel circuit. That means, so the current has started from the source, and at this node, at this junction, it has found two ways. So some of the current will pass to R1 and remaining will go towards this junction. Again at this junction, the current has found two paths. So some will go to R2 and remaining will go forward to this junction. And again at this junction there are two paths. So some will go to R3 and remaining will go for R4. So that's why. So there will be so many currents in a parallel circuit. Okay, in a series circuit there will be only one current. Okay, so this is why the current will vary in a parallel circuit, because it will find so many paths. So it has to pass in all the separate routes. It will divide at the junctions. If you go to the voltages, if you observe, so voltage across, see, same voltage 50 volts, 50 volts, 50 volts, 50 volts. What this diagram is telling? So that means voltage in parallel circuit will be same, but current will be varying. Similarly, the parallel circuit currents will have separate paths. See, I1, I2, I3, I4. So different paths. So what about the resistance in a parallel path? So we'll go according to this. we will consider this as the junction or node. So I is entering. So I is entering. That must be equal to the leaving current. So I1 plus I2. The current leaving are I1. So I1 is leaving towards R1. And I2 is leaving towards R2. So R1 and R2 are parallel. So at this junction, at this node, this I has to separate into two different currents. So that's why you can write as I is equal to I1 plus I. Okay. So now we will, according to the Ohm's law, we write as I1 is equal to V by. So since the parallel circuit, the voltage will be same. So I1 is equal to V by R1, I2 is equal to V by R2. So that is equal to I is equal to, instead of I1, I will substitute as V by R1 plus, instead of I2, I will substitute as V by R2. So if you take common, that will be V by R equivalent. So that is R equivalent, that is equal to 1 by R equivalent is equal to 1 by R1 plus R2. There are two, only two. Write like this. Or otherwise, R equivalent is equal to R1 R2 by R1 plus R2. R1 R2 by R1 plus R2. If there are n numbers, so 1 by R equivalent is equal to 1 by R1 plus 1 by R2. Dot 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 1 by Rn. That simply we can write as sigma n is equal to 1 to n 1 by R. Otherwise, R equivalent is equal to 1 by 1 by R1 plus 1 by R2 plus 1 by R3 dot dot up to 1 by Rn. So in this frame, so if it is series, you can simply add. If it is parallel, we have to write as 1 by R equivalent equal to 1 by R1 plus 1 by R2 plus 1 by R3. So we have discussed about the conductance, inductance, capacitance, and also Kirchhoff's current law, Kirchhoff's voltage law, and we have seen the problems using the KCL and KVL, and we have found the unknown quantities there, and we have discussed the resistance in the series circuit, the resistance in the parallel circuit, and also see this diagram. The source is 6 volts and R1, R2, R3. So 3 resistances are there. So these are parallel. So these nodes are telling it is a parallel circuit. So the source will, from the source the current I has started at this node. It found 2 ways. So some will go towards this. So that is 1 ampere. And remaining went here. And again it has split it into 2 parts here. So some went through R2. So the resistance R2, that is 3 ohms. Here is 1 ohm. And some went, and remaining went to through this resistance R3, that is 2 ohms. So what I have to do, I have to imagine. So the current here has I, and current went in this R1 as I1, and R2 as I2, and R3 as I3. So according to that, I will write as I is equal to I1 plus I2 plus I3 plus I3. So only 3 resistance, 3 currents. So now I know what is the value of the voltage. So now I have to find I1. I1 is equal to voltage. So in a parallel circuit, the voltage is same. Okay, but it acts as a parallel circuit acts as a current divider. So current will be varying, voltage will be same. So voltage will be same, 6 volts by R1. R1 is 1, so 6 by 1. So that is 6 amperes. Similarly, I2. So voltage is same, so that is 6 by R2. R2 is 3, so 6 by 3, that is equal to 2. And I3, so that is equal to V by R3. So R3 is 2, so 6 by 2, so that is 2. So if I add all these things, I will get the value main source current. So that is I1 plus I2 plus I3 is equal to 6 plus 2 plus 3, that is 11 amperes. And I can go by another way also, that is 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay, so because this is this is parallel circuit, so that is 1 by R1. So R1 is 1, so 1 by 1. 1 by R2, so R2 is 3, so 1 by 3. R3 is 2, so 1 by 3. So 1 by 1 plus 1 by 3 plus 1 by 2. If I simplify, I will get as the equivalent distance as 1.83. So that is equal to R equivalent is equal to 1 by 1.83. So that is equal to 0.56 volts. So now I can directly find the current I is equal to 6. Already it is there in circuit. 6 by 0.54. I get as 10.98, which is approximately same. In both ways I can find the current value from this circuit. And here we will simply observe the power is nothing but the product of the current and voltage. So watts. So here watts represent the power. So 12 volts and 200 amperes. So that is 12 into 200. That is equal to 2400 watts. So 120 volts and 20 amperes. So 120 into 20. So that is 2400 watts. 240 volts and 10 amperes. 240 into 10. 2400 watts. Similarly, 12 volts, 10 amperes. And that is 12 into 10. 120 watts. 120 into 10, that is 1200 watts. So this is showing the so our class we have will again once again. So capacitor will be having two conductor plates which is separated by the insulating material or a dielectric medium. So where the energy is stored in the form of charge or electric field. So it is represented as C and the units are farads. An inductor is nothing but a conductor turned like winding of the conductor. Conductor is made into windings with the N turns. So it will act as a inductance and it is represented by L and units are Henry and here it will store the magnetic field, electromagnetic field. So again, Ohm's law is equal to IR, so 1 by R is nothing but the conductance. So this is the relationship between the voltage and the conductance. V is equal to L into dA by dt and Q is equal to CV. And these are the formulas for representing the resistance, capacitance and inductance. And KVL and KCL. So algebraic sum of the currents at a node is equal to 0, or the sum of the currents entering is equal to sum of the currents leaving at a node is equal to 0. So with these examples we have understood simple examples. So KCL plus Ohm's law will be the nodal analysis, and here with this help of the KCL we have found the unknown I value. So we have taken the incoming. So the currents entering the node as the positive and the current leaving the node as negative, that is equal to 0. And finally, we found the unknown quantity, that is minus 7 ampere. So here also with the help of this KCL we found what is the unknown current, that is Ix. So 3 is entering, 5 is entering, 1 is leaving, 2 is entering and 2 is entering. So only 1 and Ix are, so minus 1 minus Ix. So that gave the answer as 11 amperes. So here also 5 plus 12 minus 10 minus I. So finally we got the I value as the 7 amperes. So here KVL. So the algebraic sum of the voltages in a closed loop or a closed mesh, okay, is equal to 0. So that is the KVL. So Kirchhoff's laws are 2. That is KCL and KVL. Okay, here we have solved the problem. We are having two sources. How we have to solve? If we are having two sources, we will take the highest source, highest voltage source. So that is equal to the remaining voltages. So here they have not given the voltage directly, so they have put the Ohm's law. Resistance into the current. So 8I plus 40, which is directly given, and 30 into I plus 2 into I. So finally we have solved. We got I is equal to 1 by 1.5, and we have found what is the voltage at the 30 ohms. So we have I. So I will be same in the series circuit. So I into 1.5 into resistance to 30. So we got V is equal to IR, that is equal to 45. So this also we have solved. So sending voltage, that is only one source here, that is equal to 30 volts plus 2 volts plus 1 volt plus unknown voltage V1 plus 3 volts plus 5 volts. So that is unknown voltage V1. So that is this side 30 volts plus 2 plus 1 plus 3 plus 5, that is 11. So V1 is 30 minus 11, that is equal to 19 volts per watt. So this is showing why the series circuit, why in the series circuit there will be current will be same. So since there is only one path, the current, only one current will be there, that is I. And we have found what is the equivalent resistance in a series circuit. In a series circuit, we can simply add the resistance and we can find the equivalent resistance. And similarly here, so this is a series circuit, we have to find the equivalent resistance. So 680 plus 1.5 plus 2.2 kilo. So that is R1 plus R2 plus R3. So that we will get, we got as the 4.38. So here also V total is V1 plus V2 plus V3. And here this is the parallel circuit. So you can observe there are different currents. So the parallel circuit acts as a current divider. So this is a parallel circuit. The voltages are same. You can observe. So in the parallel circuit, we will have separate paths. See here also I1, I2, I3. So there are different paths, different paths, and the resistance in a parallel circuit. So we have to write as 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So 1 by R equivalent is equal to 1 by R1 plus R2. So as we can simply write as R equivalent is equal to R1 R2 by R1 plus R2. R, there are N, we can write as 1 by R equivalent is 1 by R1 plus 1 by R2 plus 1 by R3 dot 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 up to 1 by R N. R simply we can write as sigma N is equal to 1 to N, 1 by R N. Or if you want R equivalent, so 1 by R1 plus 1 by R2 plus dot 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 up to 1 by R N. So we have solved the problem in two methods to find the current. And we have, so if you multiply the volts and the amperes, we will get the watts. So thank you for listening. Remaining things we will see in the next video. We will move forward with remaining topics in the next video. Thank you for listening.
Like, share and subscribe. Hit the bell icon for more updates.